Alright, welcome back everybody. My name is Dustin, and today we're going to be diving into two powerful techniques in C++ that allow you to make your code more readable and expressive. Those two techniques are named arguments and method chaining. By the end of this video, you'll know how to eliminate long parameter lists and write clean, intuitive function calls. So let's get started. Alright, so first up is named arguments in C++. So what are named arguments? Named arguments allow you to explicitly specify parameter names when calling a function, making code more readable and reducing the chance of errors. Unlike Python or Swift, C++ doesn't have that built in, but we can achieve a similar effect using aggregate structs and fluent interfaces. So let's imagine the problem. So up here, say we have a function, and it's going to be void create character. So say we're making a game, or you're seeing some code where we have to create a character. And you have something like this, so let's just include string, just in case it asks. Let's say you have something like this, const std string name. Then you have int for health, int for mana, int for level. And we'll just keep going down here. And int for attack power, and int for defense, and then bool for is npc. So looking at that like this looks like a lot. It's kind of convoluted. So what about when we have to actually call this function? So let's actually just do something right here. Let's go std cout character, and we can say, actually we'll say character, and we'll say name was created with HP and MP and is on NPC. Variable character. Let's actually bring this down to another line. So we have this function, and let's actually call this. So let's go void call big create character, right? This is just so we can run it inside here. We can keep all of our examples, okay? So in order to create a character, we need to call this function. And we can say create character. And now we have to put everything in. Well, so we can see all of the things here. However, what if you're just going by and you don't know what these things are? So if you just say, let's say JADE-ite. We know what these are. They're going to be health. Let's say 100, 50, level 1, attack power 10, 5, and false. So when you're coming by, and say you don't know what this function and all these parameters that are being put into this function, say you don't know that, and you come and you see this, what do these numbers mean? So you see these numbers and you don't know what they mean just by looking at them. You have to actually go to the function and look to see what those. It's like, oh, okay. So now I know what this is doing. It's health first, mana, level, attack power, and this isn't really extendable. So say we want to set something else. Well, we have to add a new parameter, and so on and so on. So every time this would get bigger and bigger. That's not a good idea. So we can actually do this in a more elegant way. So a solution would be to create a structure or an aggregate struct that will hold on to this data for us, and then we can send that in as a parameter. And since it's an aggregate struct, we can simulate named arguments. So say we go struct, we go character params, and we'll go string, and we'll just say name, and it'll just be a default value to an empty name. You can give it a name if you like. So int health, that'll be a default to 100, or let's say a default to 10 or 50. Defaults to 50, and then mana will say 0 to default. Mana See, what were they all again? I already forgot. Level, attack power, defense. Level. Start at level 1. Attack power. And we'll start that at 0. Defense power. Also 0. And then we'll say bool B is NPC. That'll be false by default. So now that we have this aggregate struct created, we can actually redo the function create character. So we'll actually just copy all of this and we will paste it here. Paste, and we can get rid of all of this extra stuff. And then we can go const character params reference, and we can just say params. Cool. Now we just got to fill this in. Awesome. So now when we call it, we'll just copy this one as well. So we're going to do the same thing. Oh, this one is B is MP. Params, B is MP. Make that cleaner. Cool. So now when we call it, so we'll change this to call named args create character. So now we can take this and we can do our character. We can go like this here, and we can go name equal to JADE-ite health equal to, let's give them 150, and then let's just say dot level is equal to 3. So it looks like we got an error here. That's because we probably don't have this set up. I swore I set this up already to C++. In order to use designated initializers, you need to have C++20 on. And it looks like I didn't do that. So let's set that up right now, C++20. Or we could go 23 preview. Let's go to 23 preview. Awesome. Look how clean that is in comparison. And you know what else is great? We don't have to worry about adding in. We only specify the parameters that we want to change. So we'll have default values, but if you only want to change certain values, say I only want to change the name. Well, that's all I have to send in. So I can take out everything and it's just the name that's changed, and this should run. From our standing, we can call this, call create big character. We'll call this here, run it. And it says that there. Let's actually add a new line at the end here. So JADE-ite was created with 150. That was all here. Where's that? We're calling it right here with these values. Right? So let's call this one as well. And we'll do some other stuff here. std out. Get some separators. Cool. Let's run both. They should be exactly the same thing, except these ones are using all default values, right? So whatever the default value was in the aggregate or named struct here, that's what's getting put in. And we don't have to worry about continually adding more and more parameters to our function calls. Now, so say we want to add in more stuff for our params. Well, let's add some more stuff in. What could that be? Let's add in a float x pause. So like, so your world positions, your x position, or y pause. Now we changed this struct, but we didn't change this. Let's run it. It should still work. Why? Because the struct was changed, but the function call was not. Because the function call takes in this aggregate struct, and we can just name the parameters that we want to change. So we can actually go x pause is equal to 50.f, and y pause is equal to 100.f. Right? And then we can, did I change that to y pause? Yeah, it's y pause there. Oh, so that's a good error actually. So right here, you have to make sure you hit the dot. So anyway, so we have that. So it changed it. We could run it. Now we're not printing the position. but that's all right. Actually, we could just add that in if we want, but it works and it runs fine. We can add any parameters that we want. The only problem is, I wouldn't necessarily call it a problem. The only thing you have to do is you have to make sure that whatever the way these were declared, that's how you have to enter these in. So if you put X pause before Y pause, it's actually going to fail and it'll give you an error. It's a very good error as well. So if I go and we highlight the error, out of order initializers are non-standard. So that's actually a good thing. And we can just move this, get rid of this here, paste this here, just like that. And it should be fine. Well, that's great. Now calling these functions are super readable, and you only need to specify what you need. The default values of the struct handle the rest. You don't have to worry about adding more and more, making more clean and readable code. But why use an aggregate struct? An aggregate struct in C++ is a simple struct with all public data members with no custom constructors. This allows us to use designated initializers, which makes the function calls highly readable. And the benefits include improved readability. Each parameter is explicitly named, reducing confusion. Flexible defaults. Only specify what needs to change and let the default values handle the rest. They're less error prone, so no more guessing the order of the function parameters. And it's easier maintenance, so adding new parameters doesn't break existing code. So you've probably seen this many times where you'll have an existing function and say you want to add a new parameter like float X pause. Well, then you'll have add a default value float Y pause. You see this a lot actually, and you'll end up with default values. The reason why is so you don't break existing code. So that's why we'll throw these default values in on the end. But what if you keep adding more and more and more? It'll just become a nightmare. Your functions will become humongous and it's more complicated. So you see more and more values here and you don't know what they are. So imagine you're not using, so I'm using Visual Studio, and it gives you the benefit where I can just highlight it and it tells me everything in the order that I'm using it. What if you don't have access to Visual Studio and you're using something like Notepad++ that's not actually going to give you that unless you somehow get IntelliSense into it, or just a regular text editor? You're not going to know what these numbers are without actually searching it up. So using this technique is especially useful for functions that would have many optional parameters in something like game settings, UI configurations, or API requests. So let's do another example. And we'll just go down here and let's make another struct. And we'll just call this, say we're doing a window, we're creating a window. You can have window config. And then you can have int width, and that's going to be 1920 and 80 for height. And up here, actually, let's put the title, std string, and that'll be the title. And that'll just be window by default. And then you can have something here. You can say bool be resizable. Did I spell that right? And then we can just default that to false. And you can add more parameters as needed. Add more. And then we just create a function, void create window. And then all this would take in is your const window config. Reference config. And do something similar. Right? So you can say std cout creating window. And we'll put the title. Big dot title. Let's put this down to a new line. And we can go big dot width. Big dot height. Get rid of this. So we can do the same thing that we did up there. We can go big be resizable. And if it is, we want to print let's actually get rid of this here. Sizable. If not, then just say fixed. Cool. And then our function to call that, we can go down here. Let's just go down here, and then we can copy this. Then we can say create window, and all we have to do now is send in our struct. So we can go dot title is equal to my game. I would say dot width is equal to, let's say, 640. Dot height is equal to 480. And then is it resizable? And we'll say true. Nice, clear, clean. We can break this down a little bit, bring this down a level. I do have the text rather big, and that's pretty straightforward. So it tells you you're creating a window, giving us a title. It's letting us know the width and the height, so we know all the parameters beforehand. These are optional, so we can just comment these out. And well, we'd have to comment that out. Comment these out, and then it would just use the default values of the window, right? So we don't have to worry about order. We don't have to worry about any, well, we do have to worry about order, but we don't have to worry about what the parameters are because we can just use their names. We don't have to guess, right? So when you see this, it's more clean, it's readable, and it's basically doing the same thing. However, it's allowing our code to be more elegant. So let's run this. Awesome. Works, it's doing its job. And if we comment these out, it should automatically use the default parameters. Bang. And it's using 1920 and it's a fixed size, so it's using the default parameters from the aggregate struct. All right, so next up is method chaining. So this is a technique that allows us to build objects step by step without cluttering up our code, or it allows you to set various parameters step by step. So let's go over a nice example. So the first thing we're going to want to do here is create a character class, something like this. Character class character. And we're going to have some members. So private std string s name. Give it no default name. Then int health 0 and a 0 and level. Sure. And then npc as well. B C. And this can be cool. So then we can create a public. So what we're going to want to do is return a reference to the character itself. So we can just chain along the methods of the character. We can go character reference. Then we can say set name const std string reference. Then we can say s name is equal to earn this. So we're returning this object here. We're returning the character, a reference to the character that we're working on right now. And we can do this for the rest of the member variables. So let's do that now. I'll just copy these down and change these. And let's create a function as well that'll allow us to print the character. This one, we won't have it as a chain method. It'll be a standalone. So print could be const. And let's actually go std. Actually, we can just go up here because I believe we have the same stuff. Copy this, create character, paste that in, get rid of all these params. S name now, health, mana. Cool. All right. We can create a character using this actually down here. So let's create a character. Let's go over here, copy this, paste this in, and let's create a character. Do this as well. Copy this. Creating character. Then we can go character R1. Then we can go char1 dot set name, and we can say John dot set health. Let's give him a 400. No mana. Like, is mana set to 0 up here? Yeah, we'll leave it with no mana, and this is going to be level 7. So dot set level. That's all you have to do. And we can just say level 7. Bang, look how clean that is. And these don't have to all be on the same line if you don't want them to be. We can actually just go like this. We can go enter here. And they can all be on separate lines, making your code cleaner and easier to look at. So it's chainable. You can keep going. You only have to do the ones that you want to do. And we just built a nice character there using method chaining. All we have to do now, we can go char1, and then we can say print. And it's going to print our character for us. Train a character using method chaining. Cool. Run it. Awesome. Look at that. Perfect. And if we change this here, say we don't want, and these ones don't matter what order you do it in. So if you look at this one, when we're using the aggregate, the order matters, right? So we're using the aggregate struct to create a window. What are we calling that? Yeah, right here. Sorry. Well, if I move title, if I change places with width, you're going to get an error. The compiler is going to give you an error, and that is a good thing. However, with this one, we can change the order. The order doesn't matter. So if I cut this and paste that here, instead, and make sure that we do this and run it, it'll still do the same thing. What this allows you to do is have your code be more flexible and more elegant and cleaner and easier to understand than if you go back up here and you just look at a function with all kinds of parameters just shoved inside of it. All right, so let's create one more function where we try to use both Fluent API also with name parameters. Let's go down here and we'll create another one, and we'll create a class called character builder. And this character builder will have a private member of a character. And then we can say public. This is going to return the character builder. So we do character builder reference. Why? Because we want to chain the methods together to build the character. And the character will already have its default parameters set up here. Even though these are private members, they're still default members. Okay? You want to make sure that those values are set to a default value that you want. And then we can say name. And all we have to do, and then we go const std string reference and name. And we can say character dot set name. That takes in name and return this. Let's actually bring this down like normal functions, because or I could bring this size down, but we'll keep it big. Turn this. This can go down the line, and we can do this for all the functions. So let's copy this, paste it once, so then we can say health int health character set health. What do we all have? So for our character class, we only have a few things. So just NPC is the last one, so might as well do that as well. Last one. NPC. Pool. And C. Set NPC. And we'll have one more where we actually build the character. And this one's not going to return the character builder. This one's going to return the character itself. So we can go character build turn. Right? Because all the parameters, whoops, I made that inside. All the parameters for the character are going to be set to this character. Then we're going to return a copy of this character. All right. So now creating the character using the character builder is crystal clear. We can just come down here and let's copy this. Creating a character using the character builder. Cool. And then we can just say character char2 is equal to character builder. Then we can say name, Jack, health, 250. And then we can say NPC. Jack is an NPC. And we just say build. Bang. So that's going to give us our character. And then all I have to do is say char2.print and run it. Awesome. Look at that. So we're using our character builder and we created character. Jack was created with 250 HP and is an NPC. Look at that. So much cleaner and better, easier to use. This makes API super friendly, super useful, and you don't have to worry about convoluted or let's say overcrowded code when you have multiple parameters like this. And that's it. So we just made our C++ code way more readable using named arguments and method chaining. If you found this useful, hit the like button and subscribe for more. And let me know in the comments below if you found this useful and any topics that you may want me to go over in a future video. All right, that's it. Take it easy.